In this lesson, we're going to talk about different types of modeling in Rhino and also how we can achieve different design styles. Whether we are in architecture or product design or industrial design or wherever, we can use the same logic. And so we started by importing stuff from outside. We started by importing an image and then we imported CAD, then we imported 3D models and also BIM or building information modeling models. And also we created in the previous video a sort of like concept design object, which in our case could be, furniture or could be also an architecture. So when you do massing and you create concepts or drafts of your model, you don't need to, specify and verify if the measures are good and everything. You can do that later. You're just like playing with the shape, so you are trying to again create a concept. You don't want to be too specific. Later on you will add details like framing and paneling and openings like windows and doors, etc., etc. So we have different ways we can work in, let's say, concept and get the initial shape of our object, of our building or product. And you can see here I have created many different shapes. Some of these are pretty soft, some of these are straight and regular. And you have so many options. You need to find your style. You can sketch also your idea and see if something comes in your mind. So usually I start with a sketch, and you can do also like a 2D sketch using curves and lines in Rhino, and then from that extract the solid. And I will show you all these techniques and tools that we find in Rhino. Just before we do this, let's also review something we did in the previous video. So we use the mesh, and we have the option to use meshes, subds, solid tools, surface tools. These are all the options we have to create shapes in Rhino. And usually I use the mesh when I want something linear and hard edged with sharp edges and corners. Otherwise, I go with the solid tools. But also you have in Rhino the subd tools, which are a sort of soft poly modeling that we find also in other software. And well, from what I can see, if you want to work with polygonal modeling, so using the mesh linear shapes and the softer curvy subd surfaces, I think it's better like in other software like Blender or Cinema 4D, etc. They work better with polygonal modeling. But in Rhino, you can definitely work better with the surface tools and the curve tools and the solid tools. So subd and mesh are an additional thing you can use in Rhino, but they're not, let's say, native. Before they were called like T-splines. And so how do they work? I'm gonna do some examples. We created this like minimalistic in a way building in the previous video, and we saw that we can use the faces and extract from them the panels that can be used then for windows and doors and openings. So what I've done here is I just changed the number of faces, because when you work with the meshes or polygonal objects, it's important to define number of faces. So if I create another one, let me go here to the mesh tools and I create a box. Now when you create this, you can see that well, before you actually define it, so let me do it again and click here on the mesh box, you can define here the creation method and also how many faces you want. For example, let's put like 3 on the X and press enter, and let's put like 6 on the epsilon and press enter. And for the Z, which I think is the more important, is the vertical, the horizontal divisions of the vertical side. So the more divisions you put, the more you will be able to put windows and doors in various positions. So I'm gonna put like, let's try with 7, okay? But you can even do more. So if I create a block like this, I don't care about the size at the moment, just want to create a quick box. There you go. So I will be able to use this to define parts of my building. And I think in this case, with these settings, it's better to go this other way, like this. Okay. So in the previous video, we created boxes and empty them with the solid tools, but similarly, we can use the mesh. So now that I have this, instead of selecting, before I select, I will go up here to the extract mesh face. So it means I can select a bunch of faces and I can extract. So for example, this could be a door, and of course I can extract them separately. I'm just gonna do once to show you, just to make it quicker. And this could be like an horizontal window, or could be like a curtain window or curtain wall. And it could have different shapes. It could be horizontal, vertical, and whatever. So let's use, for example, here to create a vertical one. And then on this other side, I'm going to create a big, like curtain wall, big panel wall like this. Okay. And then we press enter. And once we press enter, this can be extracted. And you can use them to create the panels, the framing, as we saw before. Using, for example, here we have the inset match edges. So we need to select which ones we want to extract. So let's say that I want this, press enter, and then the amount, let's say 0.1. And yeah, for each one of these, you will have then framing and panels. So be careful here. You may want to like unify those before you proceed and use this technique. And just as we have tools that help us simplify or rebuild the mesh in the solid tools, we also have it here in the mesh tools. But let me just show you another thing. You can see here I created also a thickness, and look at this. This is a closed solid poly surface. This is not a mesh actually. So why I did that? So if I use the offset, I also have the offset for the mesh, and like I have it in the solid. So if I do offset mesh, so remember what we are working with, okay? Well, we have some options here, and I'm gonna use the vertex normals as the direction, so everything gets extruded on its own direction. And then you have here average normals. You can see it doesn't work. It only goes on one direction. You can flip the side. You can offset inside, you can offset outside, you can make a solid, you can also do both side. So what's the problem here? When I do the offset with the mesh, it goes like this. So it's like inflating, it's like a balloon. And if you want to have that look, well, it could be fine, but probably you don't. And by the way, if you want this even more soft, you can use this one here to go from hard poly modeling into soft poly modeling, which is called the shrink wrap. And you have some settings here, and you can also apply a preview so you can see before you actually say okay. And what this creates is like a smooth version of your polygonal object, and it creates also all this triangulation. So if you're looking for something more organic, this is a little better. Otherwise, let me go back. So if you want instead to have more straight edges and straight corners, I suggest you convert this into a solid. If you go up here in the toolbar, you find this little kind of flag. So here you have mesh from surface polysurface. So we can convert a solid NURBS into a mesh, and with the right click you can go all the way around. So convert objects to NURBS, and this is what I'm gonna do. And I already selected this. I can choose if I want to delete the input objects or not. And also I have some mesh options. So if you want triangulated faces or not, I would say no. I don't like triangles. They're less comfortable to work with. And so let's say okay, and I'm gonna move this aside. So they're perfectly identical, but one is an open mesh and the other one is an open poly surface. It's open because I cut through this and created the holes. And I can now go in the solid tools because this is now a solid, a NURB solid. And for example, I can cap the planar holes right